Welcome, everyone. It's no secret, large language models have transformed how we approach programming challenges. Today, we'll demonstrate this by tackling a web scraping task aimed at simplifying data extraction from websites. We'll first start by understanding the motivation behind web scraping. Imagine wanting to analyze local rental prices. To get this information, we need to go to some rental website. In our case, we will use the website morgantownrents.com, which contains vital information across numerous listings. Manually collecting this data is not only tedious, but impractical for ongoing analysis. Here's where the magic of web scraping comes in. Web scraping allows us to programmatically access and extract the data we need. By inspecting the website's HTML, we can identify the patterns that our script will need to recognize. This process enables us to automate data collection efficiently and effectively. To get started, let's ask ChatGPT to do this for us. For our prompt, let's say, create an example where we parse the webpage morgantownrents.com for the links, the addresses, the number of beds, the number of baths, the location, the price, and the property type. Let's see how ChatGPT guides us through the scraping process. From the response, it suggests using Python libraries like request for fetching webpage content and beautiful soup for parsing the HTML. It also provides a code template from which we can get started from. With the script provided, let's dive into what each part does. This step is crucial for both beginners and more advanced programmers as it ensures we fully understand how our web scraping tool works. First, we import the necessary libraries, request and beautiful soup. These libraries are fundamental to web scraping in Python, allowing us to fetch and sift through web page structures with ease. Next, we see the function called request.get. This function fetches the web page content. We include headers with a user agent argument to mimic browser requests, ensuring the website treats our script like a regular visitor. This is common practice to avoid being blocked by websites. After obtaining the HTML, we use beautiful soup to parse it. By creating a soup object, we gain the ability to search through the HTML tree. This object is our gateway to extracting specific data points we're interested in from the web page. The core of our script involves locating each listing on the page using the function soup.findAll, then iterating over these to extract details like links, addresses, and prices. For every listing found, we extract data by pinpointing HTML elements containing our desired information, such as the address or price. This step shows the importance of understanding the web page structures, as selecting the correct tags and classes is key to successfully extracting the data. The final part of the response refers to the ethical considerations of web scraping, as some websites do not like web scraping. Respecting the robots.txt file and not overwhelming the server with requests are practices we must adhere to. If any part of the code is unclear, or if we're curious about optimizing our script, we can just ask ChatGPT for further explanations or suggestions. To streamline our project, we'll document and execute our scraping strategy within a Jupyter notebook. This saves time by allowing me to generate the responses from ChatGPT for you ahead of time. The notebook includes each prompt we sent to ChatGPT and the responses we received. The notebook will set up the Python environment by installing the necessary packages. We can then execute the code that is provided from the responses. The first response we got from ChatGPT gave us a template on how to parse the HTML. However, this will not work if we run it. This is because we need to know the specific HTML structure. Here, I already provide the snippet of HTML where the listings occur. Now, we will need to figure out a way to parse this information properly. To address this specific need, we can directly involve ChatGPT in refining our parsing script. By providing ChatGPT with the HTML snippet, we can ask for assistance in modifying our existing code to accurately extract the data. Based on the HTML snippet, ChatGPT provides a modification to our script that searches for the property listings within article tags. This targeted approach allows us to extract detailed information about each listing. Let's see how we extracted each piece of information. We look for A tags for the links, H5 tags for the addresses and prices, and LI tags for the beds, baths, property types, and locations. Once we've extracted the data, we compiled it into a list of dictionaries. Each dictionary represents a single property listing, with the keys representing the information of the listing. When we run our script, we encounter an index error, indicating a problem with how we're parsing the price. This error is a common issue in web scraping, reflecting the variability in web page structures. To handle this error, we have two paths. either by directly consulting ChatGPT for a solution or by implementing a try and accept block into our code. Here, we choose to incorporate a try and accept block. This ensures our script is more resilient and capable of handling anomalies in our data. With our revised approach, let's rerun the script. This time, it successfully processes the HTML snippet by bypassing previously encountered issues by assigning NaN values to any price that doesn't conform to the expected format. The script will now output a list of dictionaries as intended, where each dictionary represents a property listing. Our next challenge involves converting raw data into an insightful analysis. Let's prompt ChatGPT to help us process the list of rental properties, focusing on converting prices, beds, and baths to floats, and then analyzing these figures. Here, the response provided us with a Python script utilizing pandas to convert our list into a data frame. It then outlined functions to clean and convert the prices, beds, and baths to numerical values, making them suitable for statistical analysis. Upon executing the script, we encounter a value error due to a price containing a hyphen. As we can see, this error is similar to our previous error and illustrates how ChatGPT can have difficulty catching uncommon cases. However, these errors can easily be addressed either with our prior knowledge or with ChatGPT. To address this error, we'll refine our data cleaning function to remove any hyphen characters from the price strings. With our function updated, we re-execute the script. This time, it processes smoothly and is able to provide the statistics on our information. These statistics can reveal insightful trends about our rental properties, such as average prices, standard deviations, and the range of beds and baths available. Let's take our exploration a step further by visualizing the relationship between the rental prices and the number of beds. A scatter plot will help us visually assess the trends and outliers in our dataset, providing insights the numbers alone might not reveal. To create our visualization, let's prompt ChatGPT. Now I want to see a scatter plot of price versus beds. ChatGPT suggests using matplotlib to create a scatter plot, which is a popular Python library for data visualization. By plotting price versus number of beds, we can observe how these variables interact across our dataset. Execute the script to generate our plot. As the plot appears, we see how rental prices correlate with the number of beds for properties. From the plot, we notice a roughly linear relationship between the number of beds and price. This is somewhat to be expected because the higher number of beds corresponds to a bigger house, which is expected to cost more. There are some notable exceptions when the number of beds is 3 or 4. These deviations could be attributed to various factors such as location, property type, or additional amenities, but it warrants further investigation. To uncover the reasons behind these outliers, we'll have our scatterplot differentiate properties based on their location. This will help us see if geographical differences account for the variations in price and bed count. Here, we asked ChatGPT for a way to visualize our data with an added layer, color coding each point by location. By giving each location a unique color, we can visually dissect the influences of geographical areas on rental prices and the number of beds. The response provides us with a modified script that incorporates color coding. Let's implement this updated script and observe the distribution of properties across different locations. The resulting scatterplot, now color-coded by location, offers an illustration of how properties are distributed in terms of price and bed count across various locations. With this plot, it becomes clear that the outliers previously noted are primarily due to differences in location. Properties located outside of Morgantown, for example, show distinct price and bed count characteristics. This explains why some properties were outliers, highlighting the significant impact of location on rental property valuations. Our enhanced scatterplot not only clarifies the role of location in shaping rental prices and property features, but also invites further exploration into other factors that might influence the market. This concludes the project. Hopefully you can see how useful ChatGPT was in this process. It could successfully perform web scraping, data cleaning, and visualization tasks. While ChatGPT's initial code is a strong starting point, real-world complexities often necessitates refinements. This process illustrates the adaptability of AI encoding, where adjustments are made to align with specific web patterns, demonstrating the collaborative nature of human-AI interaction in tackling coding challenges. Thank you for joining me today. Hopefully this video has motivated you to try to incorporate AI into your workflow to accomplish your tasks.